Hi everyone. Today I would like to discuss about a very important concept, namely minimum mean square estimation. So MMSE is a class of Bayesian estimator. Um, in the last videos I discussed about Bayesian versus Frequentist estimation. I will put a link in this description to definitely watch that video. I also talk about the map versus ML estimation, which map is a Bayesian estimator as well. Um, Different from MMSE, once I talk about the Bayesian estimator, you will see that map is a 1-0 loss function and MMSE is based on quadratic loss function. But MMSE is used extensively in a dynamical system, control, signal processing, communication, machine learning as well. For example, a Kalman filter is a type of MMSE estimation. Kalman filter is an example of linear MMSE. I talk about the linear MMSE, what is that, what I mean by that in the future videos. But for now, let's make sure we understand what is MMSE, what's the idea behind MMSE, minimum mean square estimation. Okay, so here is the idea. Assume my goal is to estimate random variable x. Assume my goal is to estimate a random variable x. Remember, it's a Bayesian, so the parameter that we want to estimate is x, is a random variable, right? It's the unknown distribution. And assume the estimator has a form of estimator to be x hat, right? Very general. Now, during the MMSE, we are trying to minimize the expected residual square. What is a residual? Residual is denoted by a symbol epsilon, is usually defined as x minus x hat, right? So this is a residual. This is our parameter, what we want to estimate. And this is estimator, right? So I would say that this is a true value. It would be better to write true value. And this is our estimator. X hat is our estimator. So during the MMSE, what we are going to do is this. In MMSE, we are trying to minimize expected residual score, expected value of the residual score, right? So this x is a random variable, and therefore this epsilon is a random variable, so it has a expected value, right? So we are trying to minimize the average value of epsilon score, expected value of epsilon score. Okay, very good. So what is the setup? This quantity is equivalent to this, x minus x hat. This is a quadratic. It's equivalent to x minus x hat squared. This quantity has a very, very important name in the literature, in the estimation literature. It's called MSE, mean square error. So usually you see these two terms together, MMSE and MSE. So the goal, like other videos that I discussed, I always want people to understand the goal, what we are trying to do. Otherwise, writing a mathematical equation without understanding what we are going to do would not have any value here. And during the MMSE, the goal is to minimize the MSE, the expected residual score, the mean square value of the error, right? This is residual or error, whichever you want to call it. So we are trying to minimize this, or expected residual square. Expected means mean residual score. Okay, great. So that's what we're going to do. So what is now mechanics? Like the video that I discussed about map and ML estimations, I told you the step-by-step procedure on how to form the maximum likelihood estimate and maximum posteriority estimate of a parameter, right? Here I will do the same thing. I believe it's very important to have these steps in your mind when you are solving a problem. So what are the steps to do this? I will write a step 1. Define an estimator. First, define an estimator. Define the estimator. So in this problem, the estimator in the general case it will be x hat. Then step 2 would be form or construct would be a better word here. Construct the MSE, which is expected value of x minus x hat, the true value minus the estimated value square. Step 3, differentiate or minimize the MSE by differentiation to find the optimal x hat. This optimal x hat is known as MMSE. The x hat is the MMSE, the minimum mean square estimator. The actual estimator is MMSE. Now, in the step 4, plug the x hat in the MSE expression. I will write a step 2 to find the optimal MSE. Okay, so these are the step-by-step technique how to solve the MMSE problem. Now, in order to make sure that we're all in the same page, we're going to solve one example. Find the MMSE estimator of random variable x using the constant y. So the question is to find the minimum mean score estimation of the random variable x using a constant y. So here our estimator is given as a constant, right? If I want to estimate a random variable x using a constant y, what should be a form of y? How do I know what y should I choose? What constant should I choose? I'm going to follow the steps that I just outlined one by one. Let's see what will happen. Step 1. Construct the estimator y. It's given in the problem. It's a constant y. Step 2. Construct the MSE. So when I write it here, is equal to this. Use a capital letter for the random variable and a small for the letter for the realization or the value that this random variable can take. It's just a convention, right? Step 3, so we want to find the optimal y, right? Differentiate with respect to y, differentiate MSE with respect to y, since you want to find the optimal y, and set it to 0. I'll set it to 0. So you can use a d instead of 1 since there is only one variable. I think this is general. Is equal to right? Great. Now let's do this one. Let's perform this step. So I will write this one here first, and then I'm gonna expand this expression. It's gonna be expected value of x squared plus y squared. Y is a constant. Expected value of y squared is the same. Y is constant. That's why I didn't write the expected value. Minus 2 expected value of y x. Right? We have to taking the derivative with respect to y. Set it to 0. Now one more step. I could write it as just one step altogether, but in order to make it more clear, y squared minus y is a constant. It's not a random variable. You can take it out of the expectation. It will be 2y expected value of x set to 0. Now perform the differentiation here. This would be expected value of x squared is not a function of y. This would be 0. So this will be 2y minus 2ex equal to 0. Therefore, y is equal to expected value of x. So the best y, the best estimator, the best constant estimator for a random variable x is a mean of that random variable. Intuitive, right? It's very intuitive. Now I want to find the best. So this is the MMSE. This y is known as MMSE. Optimize as step 3. Now, step 4, plug this y, plug the estimator MMSE in part 3 in MSE expression. Great, let's do that. So what is the MSE expression? MSE mean square error is this. X minus expected value of x square. What is this? What is the x minus expected value of x square? This is just a definition of the variance. Okay, so if you want to estimate a random variable x using a constant y, the best estimator, or namely the MMSE, is the expected value of the random variable, and the best residual square or the best mean square error is the variance of that random variable x. Here I'm going to I'm going to solve one more example to estimate a random variable x using linear combination of some random variables, maybe n random variables, maybe 2 random variables. The mechanic is pretty much the same. After that, I'm going to solve some problems related to the linear MMSE. I'm going to discuss what that is. It's a very, very important concept, linear MMSE. Remember, Kalman filter is a type of linear MMSE. And then I'm going to discuss about the general formulation for MMSE after observing the data. So up to now, we haven't observed any data. We want to find the estimation of the random variable x using constant y. But what if I tell you I want to estimate random variable x after I observe random variable y? Thank you so much. And like always, if you like this video, please subscribe to the channel, like and share the video. And as I have mentioned, I have written an article online. I will put a link in the description. The article is a detailed explanation of all these essential estimation techniques you need to know for statistics, machine learning, signal processing. Please check out that article as well. Thank you so much for listening. See you all in the next video. Thanks.